When we talk about area and circumference, let's first of all talk about what they mean and the formulas for them. When we think about circumference, that's this first one. Circumference is around the edge. Think of circumference like the crust on a pizza. It's around the edges. The formula for circumference, and we'll call that C for circumference, is 2 times pi times r, where r is the radius of the circle. The radius of the circle goes from the very, very center out to an edge. That's the radius. Now, the radius doesn't have to go from here to here. It technically can go anywhere from the center to any edge of the place on the end of the circle. It's kind of like the spokes on a bicycle tire. Those are all radii of the circle. All right, now let's talk about area of the circle. Area of the circle, if we think about circumference being the stuffed crust on the pizza, the area is the actual pizza itself. It's the area inside the circle. The formula for area of a circle, area is pi r squared. Again, r is the radius, which goes from the center to an edge. Okay, let's begin applying it in ACT problems. On this first one, it says the diameter of the circle shown below is 18 centimeters. What is the circumference of the circle? So it wants circumference. That formula is 2 pi r. So I need my radius. Now when it says diameter, the diameter, and that's what this 18 is, it's from edge to edge. It's like the equator of the earth. So the radius then would be half of the diameter. That's the relationship between radius and diameter. So if this whole thing is 18, then the radius is 9. And then I'll come over here and say 2 times pi times 9. And 9 times 2 is 18. And just bring that pi along. So B is the answer. Number 29. 2 concentric circles have radii of 5 centimeters and 6 centimeters respectively. How many centimeters longer is the circumference of the larger circle than that of the smaller circle? So we're talking about circumference. So our formula is 2 pi r. We have a larger circle and we have a smaller circle. The larger circle has a radius of 6, so that's 2 times pi times 6, which is 12 pi. The smaller circle has a radius of 5, so 2 times pi times 5, which is 10 pi. And it says how many centimeters longer is the larger ones? So just subtract the 2, and 12 take away 10 would be 2 pi. Okay, number 33. The entire loop of a rope, or the length of a rope, is coiled into 6 circular loops, each with the diameter of 10, as shown below. What is the closest to the length of inches of the rope? So basically what we need to do is we need to see, okay, there's one coil, which is one time around, one pizza crust. There's another coil, a second circumference or around the edge. Then there's a third one. We could keep going. There's a fourth one, and so on and so on. But there's 6 of those. So basically, we're saying that there are 6 arounds or 6 circumferences. So if circumference is 2 pi r, if the diameter is 10, then this radius is 5. So the circumference of one of the ropes is 2 times pi times 5, which is 10 pi. But we said there are 6 of them. So multiply that by 6 and we get 60 pi. Now here's the deal. The answer is not in pi form like the last two have been. It's a number. So we need to go to our calculator and say 60 times pi. There is a pi button on the calculator, or you could just say 60 times 3.14, which is kind of the shortcut abbreviation for pi. So 60 times 3.14, and you get 188.4, which would be the closest to D. And it says is closest to, so it didn't have to be exact. Okay, the next one, 31. If the circumference of a circle is 96 pi, what's the radius? Well, circumference, we know, is 2 times pi times r. And they told us that that circumference is 96 pi. And they want the radius. So we want to know what r is. Well, let's just take this and solve it like an equation. I might divide the pi in both sides first so that they cancel out. And I'm left with 2r is equal to 96. Divide by 2. And the radius is going to be 48, which is C. Notice that they actually have 96 as an answer, so sometimes they're kind of sneaky like that, so be careful. All right, number 34. This one says that we have 4 congruent semicircles and they touch at the corners. The path, it says, from A to B along the diameters is 100 centimeters. So how many centimeters is the path from B back to A? So what they want is this path from B back to A along the arcs right here. All right, so first of all, we know that it's 100 through the diameter. So that means each one of these would have to be 25. So that path to be 100 means those would be 25 each. That means the radius, if the whole thing is 25, then the radius is 12.5. And them wanting these paths along the arcs, basically they just want the circumference of 2 circles. So if circumference is 2 pi r, but I know the radius is 12.5, multiply and get 25 pi, and that's times 2 circles. So my answer is 50 pi, which is G. Notice that in these questions, sometimes they ask for the answer in pi form, sometimes they ask for the answer in decimal form. So you just want to make sure that you give the answer whichever way they ask for it. All right, 26. Now we're going to switch over to area. It says the diameter of a circle is 6 feet. So what's the area of the circle? Okay, so remember we said diameter is like the equator. If the diameter is 6, that means the radius from the center to the edge would have to be half of that amount, or 3. Our formula for area is pi r squared. So pi times 3 squared, which is 9 pi, or h. Notice this time they left the answer in pi form. Okay, look at 25. It's another way of asking for the area. So you can see that ACT will use the area of a circle, but they'll ask it in lots of different ways. That's why it's good to see so many different types of examples. So you have this circle. They tell us the center is right here, and we want the area. Well, we need the radius. That's the radius. Well, what you know about ordered pairs is that if I'm going to be at the ordered pair -3, 4, I had to go backwards 3 and up 4 to get to that point right there. So that means this radius went out 3 units. So my area is pi times r squared, or 9 pi again, which is C. They gave it to us in pi form once again. Now, even though you went backwards, and that would be -3 if I really was talking about an ordered pair concept, but radius is the length of something, and length can never be negative, so that's why it's 3. I would have squared it anyway. It would have turned positive, but again, radius length has to be positive. Look at 41. We have a semicircular top on Ron's patio is shown below. Which of the following is closest? So this is going to be a decimal answer to the top surface of the patio, and it wants area again. So area is pi r squared. We know that if this whole thing is 12, then the radius, just this much, is going to be half of that, or 6. So pi times 6 squared is 36 pi, but this is just half of a circle. So divide that by 2 and get 18 pi. Now, if you'll notice, they gave this as a decimal, so therefore I need to go to my calculator and say 18 times the pi button, or I can say 18 times 3.14 and get 56.5. So it's a decimal, where C is the closest to that. All right, let's take a look at number 43. What is the area? So they're asking for area of a circle that has a circumference of 12 pi. So the circumference, which is 2 pi r, they're telling me that is 12 pi. So they're telling me the circumference, 2 pi r, is 12 pi. So if I want area, which is what we want, and that's pi r squared, I'm going to need to find the r value. So let's come back up here to the top, and let's divide by the pi on both sides. So they're out of there, and I'm left with 2r equals 12, which means my radius is 6, and now I can find the area. So area is pi times 6 squared, or 36 pi. So we're back to pi form again. All right, let's look at this number 42. It says 2 concentric circles are shown below. The radius of the larger circle is 10 feet, so that would be this one. The larger one is 10. And the smaller is going to be 6. And we want the shaded region right there. If we want the shaded region, basically this is what we're doing. If we have a large circle and we have a smaller circle, and if I were to take this right here, let's say you have the whole circle. So I've got the whole circle here. If I take that whole circle and I take the large circle, the whole thing, and I subtract the smaller circle, then do you see that what I should be left with, if I take, we'll do it one more time. So there's the small circle, here's the large circle, and if I take the large and subtract off the small, then I have that dark shaded region there. So the large circle has a radius, so area is pi times 10 squared minus the smaller circle, which is pi times 6 squared. That's 100 pi minus 36 pi, subtract to get 64 pi, which is J. In this particular case, they left the answer back in pi form. All right, let's take a look at 37. And you notice this set of problems that we're doing until the end, these are shaded region problems, and they're very, very common on the ACT. This says a circle with radius 4 is inscribed in this square. Which of the following is the area of the shaded region? So if I want the area of the shaded region, I'm going to take the square, that'd be the whole thing, and minus the circle. So if I had all of it, but I just took off that little circle, I would have the shaded part. So if this is 4, that means that's 4 on the other side, and the whole side of the square is going to be 8. So the area of a square or a rectangle, remember that area is length times width, or side times side, or base times height. So the area of the square is 8 times 8. Minus the area of the circle is pi. The radius is 4 squared. So 8 times 8 is 64 minus 16 pi. And notice they left it in pi form, which is just 64 minus 16 pi. Okay, let's look at this one. This one is pretty much identical to what we just did, except for they don't draw the picture. We have to draw it ourselves. It says that Hoshi is building a circular pond in a square section of her backyard. The square section measures 20 feet on every side. The pond's going to touch all 4 sides. So what's the area of the region inside the square but outside the pond? So let's come over here and sketch this. It says we have a square that's 20 feet on all sides. There is a circle that touches all 4 sides, and we want this area, again, that's outside the circle but inside the square. So again, we have a square minus a circle. The area of the square is going to be the length times the width, or side squared, or base times height, minus the circle, which is pi. Well, we need that radius. The radius just goes from the center to the edge, so it's going to be 10. So pi times 10 squared. Notice that my answers are in numbers, so we're going to need to go to the calculator and type that in. So 400 minus 100 times 3.14, or use your pi button. And when you do, you're going to get 85.8, or 86 is what it's the closest to. Okay, number 35, another shaded region. The figure below is a section of the college basketball court. The square has sides that are 12 feet long. So we'll label that. And one side of the square is the diameter of the circle, but we can see that. The shaded region needs to be refinished at a cost of $6.25 per square foot. So what's that going to cost? Well, basically, we have an entire square where we're going to subtract off half of a circle. So we're going to say a square minus half of a circle. So the square is going to be 12 times 12, side times side, or length times width, half of a pi, or, well, the radius, if this whole thing is 12, then the radius is going to be 6. So 6 squared. So that's 144 minus half of 36 pi. Type it all in, or 144 minus 18 pi. But you know your calculator how you want to do that. And you get 87.45. But that's what the area is. Now we have a cost of $6.25. So go to your calculator and multiply that by $6.25 to get $546.57, or answer C. So in this particular case, you can see how they took an area type problem and then added an extra step by making it a word problem to find the cost. All right, last one, very similar. Pablo has a deck and a pool in his backyard. The deck is in the shape of a rectangle, we can see that, with the semicircle removed. That's the pool part. The lengths or the straight sides are given, and he wants to cover that with stain. To decide how much stain to purchase, he needs the area. So let's find the area of that deck. So this time we have a rectangle minus half a circle. So we have a rectangle minus half a circle. So this rectangle here is going to be 20 times 32 minus half of this circle. Pi, well, we need the radius of the circle. So if I need the radius of the circle here, let's think about it. This whole side is 32, and so this whole side would also have to be 32. If that much is 4 and that much is 4, subtract 32, subtract 4, and that gives me 24 for all that, which means each one of these would have to be 12. So my radius is going to be 12. So I'm going to have the rectangle, which is 20 times 32, minus half of a circle. I apologize, my dog is over here rolling around and growling. This is going to be 640 minus 1/2 of pi times 144. So 640 minus 72 pi. Again, I can see my answer here is in decimal form, so go to your calculator and type that in and get 413.8, or answer K. If you'd like more help and practice with ACT Math Prep, be sure to check out the other videos on my channel. Remember to hit that like and subscribe button if you found this video helpful, and share it with a friend too. See you later.